Okay, welcome back everyone to part 2 of Flowcharts. So here we're going to get into a little bit more of an explanation about what flowcharts are and why we use them. So the first point here clearly states it's a way to visually express an algorithm. So the key word here is visually. All right, it's much more easier for some people to see the flow of the algorithm, to see what the algorithm does in its sequence of instructions by visually expressing in which direction the data is flowing to. And in that flow there will be some conditions which might split the path of the data in which direction it goes, but as long as you follow these arrows you can't go wrong in being able to trace your algorithm and eventually finding out what it does or where the errors are, if there are any, and so on and so forth. A better way to explain this is if you had to understand, for example, if you had a pipe that water was flowing through and you had the pipe that splits into two parts and you wanted to know which of the pipes spills the water first, and you were able to visually see the pipe like this, a very badly drawn pipe, and the water is flowing from here, so we know the water is going to start from this end of the pipe. You would be visually able to see that the water would spill out of this part of the pipe first. Why? Because it's closer. But being able to draw it and seeing it like this just helps much more. So it's the same with algorithms. When you are able to see these arrows and see which way the data is flowing, it's just much more better for you to trace the algorithm. It's not for everyone. Some people like the text pseudocode better, but it's all down to you. And in the exam, you might get a question which says, develop an algorithm that does such and such. And you might be given the opportunity to either develop the algorithm as a flowchart or as a pseudocode text. The question will will tell you what is acceptable, and then it's up to you to choose. Now I want to make one thing clear. Flowcharts are pseudocode as well. They are fake code. You can't put a flowchart into a compiler and have it understand what is happening. So flowcharts are fake code which are used by programmers to develop their code, to plan their code, to see what happens if they were to put certain instructions in a certain order. So when I say pseudocode text, what I'm talking about is what we saw in the previous part on the right hand side. On the bottom there was some pseudocode of the for loop. So that's like a text-based fake code, and this is a diagram fake code. So it's obviously called a flow chart. Now the next point here says that it uses symbols and shapes that have different functions. So if you haven't figured out already, we use rectangles like this to assign variables with values. We use diamond shapes like this to check conditions. We use shapes like this one over here for input and output. We're going to go over the shapes much later on, but as long as right now in this part you understand that when you are using a flowchart to develop your algorithm, you have to use the designated shapes for different instructions, because otherwise whoever's reading your flowchart will get confused about what your instruction is supposed to do. We've gone over this third point already, so I mentioned it is fake code, it is pseudocode, just in diagram form. And this last point with the symbols, as far as your exam is concerned, you will only need to learn 7 different shapes or 7 parts of a flowchart. There are in the real world many different shapes which represent different actions, such as reading to a database, contacting a server, for example. But for your GCSE exam, you don't have to learn more than 7 of these, and we're going to cover those later on in another part. All right, so let's go to slide 2, and we'll have a very quick look at how you might use a flowchart. So here we have a simple client brief which requests from us to write an algorithm that checks if the users have input the correct passkey. So there's a door, it has a lock in it where you have to go and type in a key in a number touchpad, and if the passkey is correct, obviously the door is going to open, and then they can go inside. So how do we develop an algorithm with this? Well, first we have to have a start. So we're going to use the sort of oval shape up here. We're going to say start, like that. Then we draw an arrow to indicate where the data is going to next. So first, let's output the message. So we're going to use the input-output box here. I'm going to make it quite large so we can see. And then we say output, like so. And then we'll put out the message, we'll say enter pass key, like that. And then a quote at the end. Then the next instruction here is going to be, again, an input-output box, because these shapes are used for input and output both. So then we're going to be entering our pass key. So we'll create a variable here, pass key, and we will use the assignment symbol, which is the arrow to the left, and we'll say user input. Right, so now the user has been allowed to enter a pass key. The next part of the algorithm, so the next instruction in the sequence, has to be, we have to check whether that pass key is correct or not. So we're going to use a diamond shape here, and we're going to check, we're going to say is pass key equals to 2461, like so, with a question mark at the end, because you're kind of asking a question. That's what a condition is. It's sort of a question. It's asking whether something is true or false. Now, if it is true and the pass key does match 2461, then we're going to say yes on this branch here. So we're going to say yes, as in, the answer to this question is yes, it is true that pass key is equals to 2461. In that case, we are going to say return door open, like that. But if the pass key is not correct, we're going to say no, like that. Then what we're going to do is we're going to return alarm, for example, like that. So what I've done here is I have a start to my algorithm and I have some sort of end. Okay, so we have two different endings. Not both of them will be executed. Only one of them will be executed depending on the condition. We have an output which notifies the user what they need to do. We have an input which the user can interact with the algorithm, can input some data into the algorithm. We have an if statement, in a way, that checks whether the pass key is equal to this number we are looking for. If that is true, it's going to follow this branch and return the door open function. And if it's not, then it's going to return a function which is going to raise the alarm, for example. So this is how you would turn a client brief into a flowchart.